This is going to be a walkthrough of CS88's Fall 2018 midterm exam. So let's get started with the first problem. We see that this first problem is a what would Python print? And we see here that we're given some code, and x is assigned to 2, y is assigned to 3, z is assigned to hello. And we also have this function hofun here. So getting into the problem, we have the first problem is y is divided by x. So y is 3, x is 2, and so we know this is going to be 1.5. Next problem, x mod y. So x is 2, y is 3, so 2 mod 3. So remember that modulus is basically the remainder after we divide the first number with the second number, but we know that if the first number is smaller than the second number, then we can just give the first number. Cool, so for the next part, we actually haven't really talked about this structure or this form in this semester, but I'll still go over this problem. So it's basically saying return z if this is true, else return this. So we basically have to determine if this x floor divided by y is true or not. And so we know x is 2, floor divided by 3, and so this gives us 0. And so if you remember, 0 is a falsy value, so 0 would actually evaluate to false, so we would not do this z, we would do this z times x. So z is hello, x is 2, and so if I do a string times some number, I'm basically doing like hello plus like hello, if that kind of makes sense. So what I'm really doing is it's going to give me hello, hello. Cool. So now we're going to do some AND statements. So for this AND, basically remember an AND statement keeps going until it short circuits when it sees a false, and then it returns that false value, or it just returns the last true value it sees. So let's see what length of z is, and that's 5. 5 is greater than 3, and that's true. So we keep going, so we do x. X is 2. 2 is not a falsy value. The only falsy value we have is 0, so this is also true. So this statement expression evaluates to 2, because we just returned the last true statement, because there were no falses. So now we have this foo's function here. So for this foo's function, we see that we define it here, and then we're calling it in this line. So what we pass into foo's is y, which is 3. So we can basically write a 3 here. So x becomes 3 times 3, so it becomes 9. And then finally we want to return x plus y and x. So we know this x is going to be, 9. And this x is going to be 9. So we just have to figure out what y is going to be, right? So if you remember in our global frame, we have our x, which is 2. We have our y, which is 3. And then in this foo's frame, we have our x is going to be 3 because we passed in 3 here. And then, so we want to return x plus y. Oh, x becomes 9 in the function. And so we want to return x plus y. So we would look at our own frame here, and we don't see a y. So we have to go look up into the parent frame to go look for y. And we do see a y here, which is 3. So this y here is 3. So this foo's returns a 12, and it returns a 9. So a gets assigned to the 12, and 9 gets assigned to the 9, or b gets assigned to 9. So if we just want a, it's just 12. Cool. Now moving on, moos. So we see that moos is going to return us a list because of a list comprehension, and we're passing in these 3 arguments. So we see that b is 0, c is 3, a is some string a. And so if we're doing range b BC, which is range 0 to 3. Then we're going to have the numbers. Basically, we're going to go through the numbers 0, 1, 2. And we're going to have 3 things in our list. And so I'm going to have I or A for every thing in this range. And so remember that or statements, they're going to short circuit once you see a true value, right? So we're going to see that the first I we have is 0. And so I'm going to do 0. 0 is falsy, so I'm not going to stop there. I'm going to go to the A. And A is a string, and that's a truthy value, so I'm going to be given an A. Next, I'm going to have I is 1, so I'm going to see 1 is truthy, so I'm just going to stop there and return myself a 1. And then I'm going to have 2, which is the same thing. It's truthy, so I'm just going to get a 2. And next is news. So for news, I see that I'm passing in a 1, and then Y I'm going to pass in as 3, and then I'm going to pass in a 2. So we see that for X in range C, we know C is 2, so I'm going to be doing X is going to be 0, and then it's going to be 1. And so A right now is 1, starting out. After the first iteration, I'm going to add on B, which is 3. So after the first iteration, A becomes 4. And then I'm going to iterate one more time, and A is going to be 4 this time, plus equals 3. Then now A becomes 7. Now returning A. So this gives me 7. Alright, so let's do the second part of the what would Python print. So for this first problem, I have zoos, and I'm going to be passing in this list as S and 4 as I. And so what I'm going to be doing in this if statement is checking if this 0th element of S, which is 2, is greater than 4. And 2 is not greater than 4, so I'm not going to be going into this if statement. I'm going to be doing this line. So what I'm going to be doing is returning I as a list, because remember I is 4. I'm going to make it into a list and add it to S, which is already a list. So I'm going to be making the list larger. I'm going to be returning a larger list, which is 2, 4, 2, 3, 8, 1. This was S, and then this was I made into a list. Cool, so on to the next problem. We see HOFUN. So HOFUN was actually defined up here. I just brought it down here so it's easier to look at and do. So we see in HOFUN that we're passing some function and passing some sequence, and that's exactly what we're doing. We're passing this function f and passing this sequence. So let's see what HOFUN is doing. We see that we're calling f on the sequence here and on some s. And so we get this s from the sequence. So we're iterating through the sequence and then passing in the sequence into s or f along with the given element in sequence. So what happens in the function f? So in the function f, we're returning the 0th element of s along with I, added to I. So it's going to return me a number. This returns me a number. And so we see that sequence never changes, so this S0 also never changes. It's always going to be this 1. So I'm always adding 1 to all the other elements in the list. So essentially this becomes 1 plus 1, 3 plus 1, and 2 plus 1, which is 2, 4, and 3. And so I'll just write that up here. Cool. So I'll clear this really quickly for the next problem. And so we have a new S, right? And this new S, we see that instead of returning a number, it's returning a list. So I think here I'm going to be creating a list of lists. So our sequence is still the same, but our F has changed a little bit. So when I call f on this sequence and some given s, I'm going to be doing something a bit different because I'm going to be slicing the list, right? So this s here is going to be determining the index from which I slice. So the first call to f, I'm going to have the sequence, and I'm going to have 1 because that's the first value that s is going to be. So in this thing, I'm going to be returning sequence sliced starting at the first index. So I'm going to be return a list of 3 and 2. Next, the next value that I'm going to have for s is 3. So I'm going to be slicing. So I'm going to be passing sequence along with 3. And so if I slice at the third index, right, I'm not going to get anything. So it's just going to be an empty list. Finally, I'm going to have sequence. And the last value that s is going to be is 2. So from slicing starting at the second sequence or second index is just going to be 2. So remember that all of these are in a list comprehension. So all of these turn out to be this nested list, right? Because that's what gives me there. So I'll take this thing. I'll just move it in there because I don't want to rewrite it. Cool. And so now on to the last problem. Let me clear this part. So f once again changes. And also our sequence changes a little bit too. So in this f, we're going to be iterating a set amount of times because length s never changes. Length s is always going to be 4. And I'm going to be returning j if I equals s of j, the jth index of s, else I'm going to be returning -1. So we have f on the sequence, and the first I'm going to pass in is 1. So what happens in here? So I here is going to be 1, and then j at first is going to be 0. The first value that j is going to be is 0, because remember j is going to be 0, 1, 2, 3 after each iteration, right? So s of j, which is s of 0, is 1. So in our very first iteration, we go into our if statement, and we return j, and j is 0. Right. So if you understand the pattern here, is that I'm going to be returning -1 if the given s is not in the sequence, which it never should be, or which it always should be, remember, because we're getting the s from the sequence, right? And then what I'm actually going to be giving is what index I'm going to find the very first instance of s, right? So if I have s sequence 3, that's going to give me 1 because this is the first index. The first time 3 is found is at the first index, right? And then again, I'm going to have f sequence 1, and that's going to give me 0 again because even though I'm on this this is what s is, right? This is where I find the very first 1, and it's at the 0th index, so I return 0. And finally, for my last call to f, sequence of 2, and we see that the first time I see C2, the first index I see it is at index 3. So I have a list of 0, 1, 0,